Good morning. We're on to lesson 4 notes. Today we're going to start looking at how we solve exponential equations. There's actually a few different ways to do it. The main way people usually would use is logarithms, but we aren't covering that till the next unit. So I'm going to show you a couple other ways that we can use to solve exponential equations. So first of all, what's an exponential equation? If you look down here, this is an example of an exponential equation. You want to try and figure out what x has to equal in order to make that true. And so far with all that you have done so far, you have never actually learned yet how to solve it when there's a variable in your exponent. So there's 3 different ways we're going to learn this semester. Like I said, logarithms is a really quick and easy way, but you won't learn that till our next unit once we dig into logarithms. So today we're going to solve by using common bases. So that's today's lesson. You can also solve these guys by graphing, which we'll talk about on Thursday, I guess. And then the last way, which I mentioned, is using logarithms, and we won't be doing that until our next unit when we learn more about logarithms. So today, using common bases. To solve exponential equations with different bases, you must convert them to common bases and then solve. So I'm going to skip down, because you have the copy of the filled in notes. I'm going to skip down to this one here. Basically, what you need to do is you need to write both sides of the equation using the same base. So for the 3, there's not much we can do to write that as a different base. We're going to leave it here. But now we can rewrite 81, and I want to write it so that it is 3 to some exponent. Here's a little bit of trial and error. If you know your facts really quickly, you might remember what it would be. But I have it set up so that each of these will work out perfectly. You should be able to raise this 3 to some exponent and make it equal 81. So you have to do a little bit of trial and error in your calculator and think, okay, well, that's 3 exponent 2. Well, that doesn't work. 3 exponent 3. No, we're getting closer. What about 3 exponent 4? Yes, so I can see from here that 3 exponent 4 is the same as 81. So I can rewrite this 81 as 3 exponent 4. And that's our goal. What we want to do is make sure that our bases here are the same. Once your bases are the same, then we can solve it. So if this is the same as this, then it follows that your x minus 2 must equal 4. That's the only way that both of these sides are going to be equal to each other. If this base matches this base, then its exponent has to match this exponent. So I know x minus 2 must equal 4, and then from there you can solve for x. We're going to add 2 to both sides. I can see x equals 6. We can always check our answers, don't forget. So let's do one of those. What you're going to do is rewrite the original equation, but now instead of x, I'm going to put a 6 in, and I'm going to make sure that this works. So 6 minus 2 is 4, and if I go 3 exponent 4 in my calculator, I can see that it checks out, and that must be the correct solution. So they're not always going to be super simplified, so let's look at a couple other ones which are a little bit more complicated. So the trickiest thing is to figure out what is a base that would work for everything there that's on both sides. So a base will likely be something, it'll usually be something like a 2 or a 3 or a 5 or a 10, something that'll be a bit easier to work with. I'm not going to give you something super complex and ask you to go through it. So looking at part C, I can see that a nice base that could be used is 2. And if you're not sure, try to first see if you can write them out as an exponent with 2. If you can't, try 3 or whatever if you're not super quick with your facts. So for 8, I know that's the same as 2 exponent 3. If that's not quick in your head, you're going to have to go in your calculator and test it out until you can get it to equal 8. So I'm rewriting the 8 as 2 exponent 3, and then I still have that exponent of x minus 2 there. 32, again, I can go in my calculator, trial and error. I can do with a base 2. It's going to be 2 exponent 5. It's the same thing, trial and error in your calculator. And then this one already has a base of 2, so I don't want to change it. What we want to do is make sure that on each side of the equal sign we have a base of 2 and an exponent equal to a base of 2 with another exponent, so we can compare the two. So this side is great. But on the other side, I can simplify it a bit more, and this is where exponent rules come into play that we practiced last day. Here, you're multiplying, you have the same base, so that means you can write it as a single expression, but now you add your exponents. Now we have it set up in a way that we like, because now this base matches this base, so that means this exponent has to equal this exponent. And I can just write out the exponents from here. Now we can solve this like we normally would. So you're going to multiply the 3 throughout the brackets. I'm going to minus 2x from both sides. And then I'm going to add 6 to both sides. And I can see x equals 11. And then also you can check it by popping the 11 back into here for your x's and see if both sides equal each other, which you'll see on the filled in notes. They do, so we know it works out. Same idea here. Looking at those bases, I want to try and make them all into the same base. The smallest one is a 2, and it looks like all the other ones should work with a 2. So let's use that as our common base. So the first one I don't have to change. I'm going to make this a dot instead of an x, just so it doesn't get confused with my variable that's an x. For the 4, again, 4 is the same as 2 squared, so I can rewrite that as a 2 squared. 8 is the same as 2 to the 3. 128, we're going to have to do a little bit of trial and error to figure out that one. So I'm going to go back in my calculator and say, okay, what about 2 exponent 5? That needs to be a bit bigger, so 2 exponent 6. Not quite, 2 exponent 7. Now I have my 128 that I'm looking for, so I know that it's the same as 2 to the 7. So I'm going to write 128 as 2 to the 7. Now we have to simplify it a little bit. On the left-hand side, we're multiplying all those, which means we can add our exponents and write it as a single expression. So I'm an x plus 1 plus 2x plus 1 plus 3x plus 1. And I've written it as a single expression using my exponent rules. This side doesn't need to be simplified. And now you have same base are equal to each other, which now means your exponent must equal each other. So now I can just break down that exponent and write it out. And now it's all about simplifying to make it easier to deal with. So let's multiply out our brackets to get rid of them. So I'm going to be left with an x plus 1 plus 2x plus 2 plus 3x plus 3 all equals 7x. I'm going to group all my like terms. I have an x plus 2x plus 3x is a 6x, and I have a 1 plus 2 plus 3, which is a 6. And now I'm going to minus 6x from both sides, and I can see my x equals 6. And again, you can plug it in and check your answer to see if you did it correctly. Okay, let's do a couple more. Part E is pretty self-explanatory. Common base would be 2. Let's look at F. So right away, I know 2 is not going to work. There's no 2 to some exponent that's going to give me 27. But that number kind of sticks in my head related to 3. So let's make our common base 3 and see if it works. So trial and error in your calculator if you don't know, but 3 exponent 3 is the same as 27. So I can rewrite that first side like this, means the same thing. Now if you notice I have a 1 over 9, can I write that with a base of 3? Yes, you can. 1 over 9 is the same as 1 over 3 squared, right? So now all you have to do is get rid of that fraction, pop that 3 squared to the top, that becomes a negative exponent 2. And then we have a 2x minus 5. Now you can see that we have matching base, so that means my exponents must also be equal. If this equals this, then my exponent has to equal the other exponent. Then we just multiply throughout the brackets to get rid of them. And then I'm going to add 4x to both sides. And then I'm going to minus 9 from both sides. And now to get x by itself, I'm going to divide both sides by 7. Again, if you want to check your answer, you can pop it back in. It'll take some extra brackets and work with your calculator, but you should see each side equals the other. I'll go through G. So again, trickiest part is probably thinking what is the best common base to use. From all my experience, I can see it's 2 right away, but if that doesn't come to you right away, you're going to have to kind of work with it and figure it out, what will be the best common base. Like I said, it'll usually be something easy, like a 2, 3, 5, or a 10 is usually what they are. Okay, so I'm going to rewrite this all with base 2. So on the top, it's going to be 2 cubed. That's the same as 8. On the bottom, it's going to become 2 to the 4, because that's the same as 16. And 32 is the same as 2 to the 5. Now I have all the same bases, but on this side, I want to write it as a single expression. So using your exponent rules that you all practiced previously, you can see when you divide, you have to subtract your exponent. So base stays the same, and then I can subtract my exponents. Okay, and from here, if this base equals this base, then this exponent must equal this exponent if both sides are equal. So I'm going to rewrite the exponents out and solve for x. Multiply through the brackets to get rid of them. Remember, this is a negative 4 times both of these. That becomes a negative 8x plus 4. And this one here becomes a 15x minus 20. We're going to group all our like terms together. So here I have a 3x take away an 8x. That's a negative 5x plus 22. I added 5x to both sides. And then I added 20 to both sides. And then I have to divide both sides by 20 to get my x by itself. Then you can simplify this fraction. You can divide it to out of top and bottom to simplify it. So you can see your x must be 21 over 10. And that's the answer to that one. We'll go through H as well. This one has a fun radical added into it. So if I look at this one here, again, I want to write it with the same base so I can compare the exponents. Looking at those numbers that are in the practice from the last page, I can see a 2 will be a nice common base. So first, we're going to have to get rid of this radical. So remember how we write that. So first of all, I do want it to be a base 2. So I know 2 to the 7 is equal to 128. Again, if you were quick to know that, I obviously have it in my notes already, then you would go into your calculator and you'd keep pressing it until you got it to equal 128 and saw what it was. So now I can rewrite that as a exponent. Remember, if there's no number here, it's actually a 2. So the bottom of my exponent's a 2, the top will be a 7. So that's the same as 2 to the exponent 7 over 2. Then for 32, it's the same as 2 to the 5. And now you can see that our bases match. So that means our exponents have to match. So I know 7 over 2 has to equal 5, 2x plus 1. So I'm going to get rid of my brackets by multiplying out. Then remember, remember from solving rational equations, we don't really like to work with fractions. You could have turned this into a 3.5 if you really wanted to, but we know how to work with these. Let's multiply everything by 2 to get rid of the fraction. Okay, and then now I'm going to minus 10 from both sides. And I'm going to divide both sides by 20. And I can't simplify this anymore, but now I've figured out what my x is. So this comes in handy. Remember we went through word problems before with exponential growth and exponential decay. I purposely left out questions where the variable, what you're trying to find, is in the exponent, because you haven't learned how to do that yet, but now you can. So let's look at, let's look at number 2. So remember, let's sort out our information first. Okay, so it says a bacterial culture doubles every 3 hours. So remember, doubling is your B, and whatever time it's matched with is your P. We want to know how long it will take for the culture to quadruple. So it doesn't tell me much else other than that, so I don't know the starting amount exactly, so I like to think of it as in percents. We're starting with all our sample, which is 100%, and we want that to quadruple. That means we want it to be 4 times bigger. So my end result would be 400%, 4 times bigger than my starting amount. So you don't even have to really know a starting amount as long as you have enough information. You can then just imagine that you're starting with 100% of your sample. So my A is going to be 1, my Y is going to be 4. And then we can plug it in. So the equation is there. My Y is 4, my B is 2, T is what I'm trying to figure out, my total time it takes for it to quadruple, and my P is 3. So from here, let's clean it up a little bit. I don't need that 1 in front. So it's the same as this. Like I said, now you know how to, one method that can be used to solve it is using common bases. So to figure out what T is, I want to make a common base. So I can see that a common base here would be 2. So instead of 4, I'm going to write 2 squared. Now your bases match. So that means your exponents have to equal each other. And now we can solve for T by multiplying both sides by 3. So I can see that T is going to equal 6 hours. Same unit as your P was in. So it'll take 6 hours for that bacterial culture to quadruple. So number 3 I won't go through, but you can look through the filled in copy of the notes and make sure you come and talk to me anytime if you have questions or join in for Google Meet if you want me to go through anything. Have a great rest of your day.